The problem for today's video is picture. So in this problem, we're given a few of these rectangles and we're asked to find the perimeter of these overlapped rectangles. So here the perimeter will be this whole side, and also you have to add the perimeter of these inside hollow rectangles. So to do that, we can consider each of these rectangles as separate coordinates, and then we'll sweep through all of these different coordinates and count all of the perimeters. So to do that, I will create a few structures. This will be the structure for the horizontal lines, and this will be the structure for the vertical lines. So for every horizontal line, it should have a y-axis, a y position, and then a starting x position and an ending x position. So this basically represents that there's a line on this y coordinate, and it has this length. And then here this L will represent, this L can either be 0 or 1, and 0 will represent that it's the starting of a rectangle, and 1 will represent that it's the ending of a rectangle. For example, here, let's consider this big rectangle here. Then this horizontal line, the bottom one, will be considered as the starting line for the rectangle, and then this line here will be considered as the ending line for the rectangle. And this is the same thing for the vertical line, but here we swap the coordinates, so this should have one x coordinate along with starting y position and an ending y position, and also we need to record the starting and ending of this vertical line as well. So going back to this rectangle, the line on the left side of this rectangle will be considered as the starting line, and then the one on the right will be considered as the ending line. So then here we will need to sort this later on. So I created two functions to compare different lines. For comparing horizontal lines, we should sort the lines in increasing order according to the y coordinate. So the y coordinate should be smallest in the beginning and then greatest in the end. But if we have similar, if there's ties, then we have to compare the starting and ending point. We should always consider the starting lines first and then consider the ending lines. So if this L for the first horizontal line is smaller than the second one, we should put the first one in front. And this is the same for the vertical lines, but here instead of comparing y coordinates, we're comparing the x coordinates, basically the starting position or the position of this current line. So then here I'll create two vectors. One is to contain the horizontal lines and the other one contains the vertical lines. Every time we're reading an input, we will push back two horizontal lines. One is the starting horizontal line and one is the ending horizontal line. So these two horizontal lines both have starting and ending x position of x1 and x2, and then the starting one should have the starting line should have the smaller y coordinate, so it should have y1, and then the second one should have y2. And then here we have to set this to 0 and 1. This is also the same for vertical lines, but here swap the coordinates, so you have y1 and y2, and then x1 and x1 and x2 here, but also 0 and 1. So then here we will sort both of these vectors according to their starting positions, and then we will use this answer to keep track of the total units of perimeter. Here I will create this count to keep track of basically the opening and endings for a different position. So you can think of this as an opening bracket and closing bracket. So we should only check the ones where the closing brackets and opening brackets are complete. So when they're complete, it means that they're 0. So we can go through the horizontal line first. So if this is an opening line, if this L is equal to 0, then we will set this to 1, because later on we will just increase the count of every coordinate inside this x axis of these two x positions. So we will loop through all of the x positions that are contained within this current line, So we will increase one by, we will increase all of those positions by 1 if this is an opening line, and if it's a closing line, we'll decrease it by 1. So this is why I have to set 1 and -1. If this is if the current L for this line is equal to 1, then we should set this to -1. So later on we can decrease by 1 every time, basically meaning that there's basically one closing bracket for this line. And then here, since there are negative numbers, I have to increase the coordinates by 100,000, because that is the limit for the coordinates. So then here, instead of using 100,000, we should use 200,000. And now we will check if this count for this current x position is equal to our the L for this current line. So what this basically means is that for starting lines, this should have 0. This CNT should be equal to 0, because that means we're basically starting a new rectangle. And so if we're starting a new rectangle, this means that there are more coordinates for us to add onto, or there are more parameters for us to add onto. So that way we should increase our answer by 1. And this is also the same for the closing lines. If it's a closing line, then this L should be equal to 1. And so our CNT should be equal to 1, which is correct, because that means there's currently one rectangle which is still open. And then after we put in this closing line, there should be 0 now. So every time we meet one of those conditions, we'll increase our answer by 1. So basically counting the perimeter unit by unit. And then after we finish all of the lines for the horizontal lines, we should reset our CNT to 0 again and loop through that for the vertical lines as well. So for example here, we would look at all of the lines. Then in this one, let's first ignore these two rectangles from the outside and just look at these rectangles on this side of the picture. So first, if we're looking at the horizontal lines, we will start at the one with the lowest y coordinate, which is this line here. And so if we're looking at this line, then all of these CNT will first be set to 0. So if we check all of this, then the perimeter, our answer should increase by this whole length. And then we will look at the next line, which is here. So here, let's look at it more closely. Then this part will, so this actually overlapped a bit, and it's this part. So here our CNT in this small area will be increased to 1. And so when we're looking at this line here, this small area or this small length of this side will not be considered. So it will not increase the answer, because this CNT here is not equal to 0, which means that this is still an ongoing rectangle. So this means that the ongoing rectangle will overlap this current area inside this next rectangle. So we will look at this side of the rectangle, and since the CNT for all of these x coordinates are equal to 0, we will increase our answer by this much. And then this will just look for the next one. And then so after we finish looking at this opening line, we'll be looking at the ending line for our first rectangle. Then when we are looking at the ending line, we will also do the same thing, but here this part of this side is set to already more than 1. So this part will not be increased, will not increase our answer. But this part here, this empty part, since there's no other rectangles in this whole area, then the CNT for this x, starting from this x coordinate to this x coordinate, will all be set to 1, because it's just this one edge from our first rectangle. So then here, when this is all equal to 1, this means that if we add an ending line to this current position, then this will close our rectangle. So then this will mean that it's an edge from the outside, so we should increase our answer by this much. And then so this will just keep on going, and this will be the same for vertical lines. But here you're starting at this place and then going to this line and then this line, and just keep on going like that. So here we should not go all the way to less than or equal to, because the length of this line is basically equal to x2 minus x1. And if we go all the way from x1 to x2, then that will give us a length of x2 minus x1 plus 1, and that will not give us the correct length. So we should only go to this x2 minus 1. And just the same for vertical lines, we should only go to y2 minus 1. So every time we check for these new lines, we will increase our answer, and finally we can print out the answer, which is the total perimeter of this shape.